All right, guys, here's the last couple examples from section 6.4. The directions say find the average rate of change. Well, I hope you guys remember that when you're asked to find an average rate of change, that's just a fancy way to ask you to find slope. And slope is defined as the change in y over the change in x. And in order to find that, you need ordered pairs. So you're going to have to create ordered pairs in order to find the change in y over the change in x, right? It's slope. So change in y over change in x. All right, let's give it a go. So in example A, they want you to find the average rate of change from 0 to 4 pi over 3. So this is assumed to be an interval they're giving you, an interval of x values. So what is the average rate of change from when x is 0 to when x is 4 pi over 3? Well, in order to create ordered pairs, you have to plug this number in as x, get an output, create an ordered pair, and then plug this in as x, get an output, and create an ordered pair. So one at a time, plug 0 in and plug 4 pi over 3 in and create ordered pairs. All right, so here we go. First, let's plug in 0. So to plug in 0, we're going to find f of 0. Well, that's going to be cosine 0. Well, guys, what is the cosine of 0 radians, right? The angle goes in and the ratio comes out. So what is your cosine ratio for 0 radians? Well, picture your unit circle, right? 0 radians is right here. What ordered pair was that on your unit circle? That was the point 1, 0, 1 to the right. The cosine at 0 radians is the x-coordinate, which is 1. So the cosine of 0 is 1. So that means when 0 went in, 1 came out. You have just created the ordered pair 0, 1. All right, hold on to it. Now we're going to use it when we go to find slope in a minute. Now we got to plug the next number in, 4 pi over 3. So now we have to find f of 4 pi over 3, which means you're going to be finding the cosine. Oops, let me move this up. You're going to be finding the cosine of 4 pi over 3. So what ratio do you get for the cosine of the angle 4 pi over 3? Well, remember, 4 pi over 3, you got to find your reference angle. What quadrant did it land in? Where do 4 pi over 3 land? Well, in the world of pi's over 3, pi is 3 pi over 3. So your fourth pi over 3 would be right here in quadrant 3. And who is the reference to 4 pi over 3? 1 pi over 3. So when you find the cosine of 4 pi over 3, you're really finding the cosine of pi over 3, which is 60, but he landed in quadrant 3. So what ratio do you get? What is the cosine of a pi over 3, a 60? Guys, what's the cosine of a 60? Right? Cosine 60, adjacent over hypotenuse, it's 1 over 2. It's 1/2. So the ratio is 1/2, but if that angle landed in quadrant 3, is that ratio positive or negative? All students take calculus. Take means that only the tangent ratio for an angle in quadrant 3 is positive, which means the cosine of an angle in quadrant 3 would be a negative ratio. So that's negative 1/2. So that means when 4 pi over 3 went in, a ratio of negative 1/2 came out. Now again, I know I made you go through that, but you could also have looked on your unit circle. The cosine at 4 pi over 3, what is the x-coordinate at 4 pi over 3? It's negative 1/2. The answer is negative 1/2. All right, so now all you have to do is find change in y over change in x using these two ordered pairs. So change in y over change in x. So change in y's would be 1 subtract negative 1 over change in x would be 0 subtract 4 pi over 3. And now your average rate of change is going to be weird. Look at the numbers you're working with, right? Oh, sorry, I wasn't on camera. All right, so now just figure out what this slope is. So this becomes plus 1 plus 1/2 is 1.5, which is 3/2 over 0 minus 4 pi over 3 is negative 4 pi over 3. So this is your average rate of change, your slope, but you got to clean it up. We don't want a complex fraction. So let's times by negative 3 over 4 pi. Get rid of that. times by negative 3 over 4 pi, and you're going to get negative 9 over 8 pi. And that's your average rate of change, as weird as that looks. That is your average rate of change on the interval from 0 to 4 pi over 3 for that function, okay? All right, let's do the last example and be done. Okay, now we have to find the average rate of change for this function on the interval from pi to 3 pi over 2. So again, you have to create ordered pairs by plugging these inputs in and getting outputs out. So first, let's plug in pi. Let's find f of x equals the sine of x over 2. So first, let's plug in pi. So let's find f of pi. If you plug in pi, I'm so bad at being on camera today. If you plug in pi, you're going to be taking the sine of, pi goes in for x, and then divide it by 2. Well, that means you're taking the sine of pi over 2, actually. And what is the sine of pi over 2? Well, guys, picture your unit circle. Here's pi over 2 radians. The sine would have been his y-coordinate. What's the y-coordinate at that point right there? It's 1. So that means when pi went in, 1 came out. So that's the ordered pair pi, 1. So you're going to use that to find your slope in a second, all right? Okay. Just wanted to make sure I'm using the correct problem. Yep, I am. Okay, so now we have to plug in, what was the next one on the interval? 3 pi over 2. So now you have to plug in 3 pi over 2 into this function. So let's find f of 3 pi over 2. Well, when you plug 3 pi over 2 in, it's going to be the sine of 3 pi over 2 goes in for x, and then it's technically divided by 2 according to how this function works. So we got to clean this up. Who's really our input when you plug in 3 pi over 2? It actually becomes, if I times this by a half, you actually are taking the sine of 3 pi over 4. Okay? Well, where does 3 pi over 4 land? The sine of 3 pi over 4? Well, in the world of pi's over 4, pi, this is 4 pi over 4, which means 3 pi over 4 would have landed in the quadrant right before it. So really what you're doing when you're taking the sine of 3 pi over 4, his reference angle is pi over 4. You're taking the sine of pi over 4 and it landed in quadrant 2. Well, what is the sine of a pi over 4? A 45-degree angle. Well, if you can picture your 45, 45, 90, 1, 1, root 2. What was the sine of a 45, a pi over 4? It would have been 1 over root 2. That's root 2 over 2. All right, but now remember, is that a positive or negative ratio? Well, according to All Students Take Calculus, student says that the sine of any angle in quadrant 2 gets you a positive ratio. So the sine of an angle in quadrant 2 would be positive. So that's positive root 2 over 2. So that means 3 pi over 2 went in and positive root 2 over 2 came out. And that's the ordered pair you'll use. And again, just to remind you, on your unit circle, if you took the sine of 3 pi over 4, here's 3 pi over 4, the sine would be his y-coordinate, and it's positive root 2 over 2. So we definitely got the right ratio out. All right, well, here we go. We have to use these two ordered pairs to find the change in y and the change in x. So change in y over change in x. The change in y would be 1 subtract root 2 over 2 over change in x would be pi subtract 3 pi over 2. Okay, well, let's get a common denominator here. If this one I have to subtract, I need a denominator of 2. Well, 1 is 2 over 2. All right, and then if I get a common denominator here, that would be 2 pi over 2 minus 3 pi over 2. All right, so what am I going to get? On top, I'm going to get 2 minus root 2 all over 2. And then divided by, well, 2 pi over 2 minus 3 pi over 2 is negative 1 pi over 2. Okay, and then let's clean that up. Let's times by negative 2 over pi times by negative 2 over pi. So my 2's end up canceling, and you can do this two ways. You can think of this as he's left and a negative pi is left, so it becomes 2 minus root 2 over negative pi, right, is one answer. Or if you distribute your negative, it becomes negative 2 plus root 2 over positive pi, if you want to think of it like that. Either one of these would be acceptable answers as your average rate of change on the interval from pi to 3 pi over 2. Okay? All right, that's it for this section. Let me know if you have any questions. Good luck on the homework, and please reach out to me if you need any help. I am here to help you if you need it. Good luck.